Assalamualaikum and hi everyone. We are Group Thread from BITS 1213 operating system. In this video, we will demonstrate the implementation and configuration of our private virtual network using VirtualBox. As you can see, we have created two virtual machines. First, we have BITS 1213 server and second, we have BITS 1213 client.
Here I will show the network adapter configuration for the Linux server. The server has two network adapter configured. Adapter 1 is set to NAT, which allows the server to access the internet. Adapter 2 is set to internet network, which enables the server to communicate with the Linux client within the private virtual network.
I will show the network adapter configuration for the Linux client. The client has network adapter set to the internal network, allowing to communicate with the server only. Now I will start the Linux server and verify the IP address. As you can see, the server 8 interface has been configured with the static IP address of 192.168.1.254 with the subnet mask 255.255.0.
For the ping test, I will demonstrate the network connectivity testing. First, I will ping google.com from the server to verify internet access. As you can see, the server can successfully access the internet. Next, I will switch to the Linux client and ping the server at 192.168.1.254. The ping is successful, confirming that the client and server are connected within the private virtual networks. This concludes our group demonstration.
Assalamualaikum and hi. My name is Aida Davita binti Muhammad Azhari with matric number P03251011. For my individual task, I am responsible for configuring the dynamic host configuration protocol DHCP service. In this demonstration, I will show the DHCP server configuration and the testing procedure to verify that the client receives an IP address automatically from the server. First, I will show the network configuration of the Debian server. The server has two network interfaces. The first interface uses NAT to provide internet access, while the second interface is connected to the internet network with the IP address shown. These interfaces will be used by the DHCP service to assign IP addresses to the client. Next, I will show the DHCP interface configuration. The DHCP service is configured to listen only on the internet network interface. This ensures that only devices connected to the internet network receive IP addresses from the DHCP server. After that, D is the DHCP configuration file. The DHCP server is configured to assign IP addresses from 192.168.1.5 to 192.168.1.10. The default gateway is 192.168.1.254 and the subnet mask is 255.255.255.0. These settings will be automatically provided to the client whenever it requests an IP address. After completing the configuration, I restarted the DHCP service. The service status is shown as active and running, indicating that the DHCP server is operating correctly. Next, I will switch to the Debian client. The client requests an IP address from the DHCP server using the DHCP protocol. After that, I will verify the client IP. The client successfully received the IP address which is within the configured DHCP range. This confirms that the DHCP server is functioning correctly. Next, I perform a connectivity test by pinging the server. The client successfully received reply packets confirming that communication between the client and the server is working properly. Now I will switch back to the Debian server. I will test the internet on the server by pinging the google.com. The Debian server successfully accessed the internet because it is connected to the NOT adapter. Back to the Debian client again. Finally, I test internet connectivity on the client. The client cannot access the internet because it is connected only to the internal network. This is the expected result according to the project topology. In conclusion, the DHCP server has been successfully configured on the Debian server. The client automatically receives an IP address from the configured DHCP range and communicates successfully with the server. The testing result confirmed that the DHCP service is functioning correctly according to the project requirements.
Assalamualaikum and hi, my name is Nurshifa Shamimi, and in this video, I will demonstrate the configuration and testing of the SFTP server for the BITS 1213 operating systems project. First, I will open the Linux server virtual machine which is already running in VirtualBox. Here, I will verify that the OpenSSH server has been successfully installed. Enter the password and it's currently active, and as you can see, it's running on port 22. Next, I will show that a dedicated SFTP username SFTP user has been created in the system specifically for SFTP access. Here, I will show the SFTP directory structure. The upload folder has been created inside /var/SFTP and is owned by SFTP user. Now, I will show the SSH configuration file where the SFTP settings have been configured. After click enter, it will appear like this. Then, press Ctrl N and it will show this. As you can see, the match user SFTP user block restricts the user to SFTP access only within the chroot directory /var/SFTP. Then, press Ctrl X to exit. Next, I will switch to the Linux client virtual machine to perform the testing procedure. From the client machine, I will connect to the SFTP server using the command sftp user at 192.168.1.254. Enter the password, and after entering the password, the connection is successfully established as shown by the message connected to 192.168.1.254. Next, I will navigate to uploads directory and upload a test file to the server. As you can see, the file has been successfully uploaded with 100% transfer completion. Finally, I will download the file back from the server to the client to verify the download functionality. The file has been successfully downloaded with 100% completion, confirming that the SFTP server is fully functional. That concludes the demonstration of the SFTP server configuration and testing. The SFTP server has been successfully configured on the Debian Linux virtual machine and tested from the client machine. Thank you.
Hi everyone, my name is Nisa Precious-Wani binti Baharul, B0325101191. I am a webmaster for Group Thread. Today, I'm going to demonstrate the step-by-step configuration and verification testing procedure for the Aperture 2 web server deployed for the ITS 1213 company. We must ensure our package lists are up to date. To do this, our server needs an active internet connection via adapter 1, which is temporarily set to NAT. I will run the update command sudo apt update. As you can see, the repository lists have updated successfully. We install the Aperture 2 HTTP web server package cleanly using the apt manager. The command is sudo apt install aperture 2 -y. The package is installed cleanly and runs natively background demos on our system. Let's check the live memory execution to ensure our server started perfectly. We do the command sudo systemctl /aperture 2. The output confirms the status is active running since our last boot cycle. Let's check the live memory execution to ensure our server started perfectly. We do the command. To align with our company guidelines, I personalize the default page located at /var/www/html/index.html using the nano editor. The command is sudo nano/var/www/html/index.html. Inside the document root, I've embedded our custom heading, Welcome to the ITS 1213 company private web portal, our group name thread, and my name as a web server, and the success service configuration status. To align with our testing, I go to the settings and network on the server. Under adapter 1 NAT, I untick virtual cable connected. This drops the outside internet connection entirely. Meanwhile, adapter 2 remains safely attached to our internal networking profile namespace INTnet. Now, let's jump over to our isolated Linux client. First, I'll display the network configuration using IPA. You can see it is cleanly bound to the internal network interface. Next, I'll ping our server at 192.168.1.254 to ensure internal packet line connectivity. We have an immediate response link with 0% packet loss inside our private LAN network. Let's pull our custom localized homepage directly inside this isolated termination environment using the text data transfer utility tool curl. The command is curl http://192.168.1.254. The application layer successfully fetched the custom code from our web server. Right here at the bottom of raw payload data, it prints Welcome to the ITS 1213 company private web portal, group name thread, webmaster Nusa Rizwani binti Bahru. This proves that our isolated private client-server framework can run localized web service seamlessly without relying on external connection path.
Hello, my name is Suresha Tanapal and this is the demo database. I will showing database server component of operating system group project. The Debian Linux server has been configured as a database server using MariaDB, which is open source of relational database management system. First, I will log in into the MariaDB server using the root account. This confirms that the MariaDB service is installed and running correctly on the Debian server. Now, I will display all the existing databases on the server using the show databases command. And as you can see, our database company is listed here along with default system databases. Next, I will select company DB using use command that message database changed. Confirm that the databases is now active and ready for the further operations. I will now display the tables inside this database using show tables. Here we can see the employees table which stores our sample company data. Using select all from employees, I can retrieve and display the all existing data in the current table. For testing purpose, I will first clear the existing records using delete from employees to ensure the clean insert the test. Now, I will insert 3 new records into the employees table: Ali as a manager, Siti as a developer, Kumar as a designer. Using the insert command, this system is written query OK and 3 returns query OK and affected confirmed data was successfully inserted without error. For the test 2, to verify the insert operation, I will select all the employees again as shown as all the records have been successfully stored and correctly displayed. For the test 2, I will verify the integrity data. Finally, to confirm the overall integrity of the database, I will run the show tables once more again, verifying that the tables are correctly and accessible after the all insert and retrieval operations. This is giving the correct, verifying the tables are having the accessible after the insert operation.